it's like friction, preventing electron from moving leftward.
There's an imbalance.
Yeah, we have three types of equilibrium. You were right. The mechanical equilibrium is the when the total force is zero and the total moment acting on the object is a system is also zero. It is mechanical equilibrium. Now, and then we have thermal equilibrium in thermophysics, in thermodynamics. Okay, thermal equilibrium say that when the two objects are in contact and they have the same temperature, which is thermal equilibrium, there is no heat, no thermal energy exchange, transfer from one object to another when they are in contact. Okay, and this is the third thing, electrical equilibrium. That electrical equilibrium means that the electric force Fe equal the magnetic force Fb acting on one electron, on each electron. Okay, and this force F is e to the right, preventing electron from moving to the left, from moving leftward. When these electrons, which are free, move in a magnetic field, they experience magnetic force, which is determined by the rule FBI. Okay, and we have identified here that the magnetic force Fb is leftward. Let me highlight this thing, pulling electrons to the left end of the rod, creating a potential difference between the two ends. The left end is negatively charged and the right end is positively charged. There is a potential difference V between them, between the two ends. Okay, so this is electrical equilibrium. The electric force equal to the magnetic force, which means total force is zero, which is similar to mechanical equilibrium. Electric force is the charge Q of an electron. We normally use the small e here to indicate elementary charge electron. And this is the field strength E. The product E times E, charge times field strength, okay? Because field strength is force per unit charge, is the electric force, and the magnetic force is QVB, where Q is the charge. I think we'll replace E here by Q also, so that they look the same thing. QVB, we have this formula in the booklet. Actually, the correct form is sine of an angle, but in this case, the angle is 90 degrees. So sine of 90 degrees is 1. Okay, 90. That angle is the angle between the velocity vector of the electron, the charged particle, and the magnetic field B. But in this question, and 99.99% of the question in IB, we deal with the case that the angle is always 90 degrees. Not any other more complicated case, different angle. Okay, so you can forget about the 90 degree, it doesn't matter. So we have this equation QE equal QVB. We can simplify the Q, so E electric field is just V, which is the speed, and the field strength or magnetic flux density B. Also, we have another formula in the booklet, which is potential difference V is EEV over D, potential difference divided by the separation, this one, So this E is the potential difference over D separation, which is the length, D distance in the formula. You can check the booklet, okay? Is the length of the rod equal VB, okay? Therefore, we have proven that the potential difference V, this is the big V, potential difference, okay? This is little v, the speed, B, V, L.